Does the electron decide its nature in our brain? Wave-particle duality explained. Today we will talk about one of the strangest ideas in physics. The wave nature and particle nature of the electron, and a popular claim that this nature is created by our brain or belief. This topic is important not only for exams, but also to avoid misunderstanding quantum physics. Let us begin. Electrons were first discovered as particles. They have mass, they have negative charge, and they move from one place to another. In electric current, electrons flow through wires like tiny particles. In cathode ray experiments, electrons travel in straight lines and hit a screen at specific points. All of this clearly shows particle behavior. But later, scientists discovered something shocking. According to Louis de Broglie, every moving particle has a wavelength. This means electrons should also behave like waves. This was not just a theory. In the Davison-Germer experiment, a beam of electrons was fired at a nickel crystal. Instead of scattering randomly like particles, the electrons formed diffraction patterns. Diffraction is a property of waves. This proved that electrons show wave nature. So electrons show both particle and wave behavior. This is called wave-particle duality. Now comes the confusing part. Many people say the electron becomes a wave or a particle because of our observation. Some even say our brain creates the reality of the electron. This sounds deep, but it is mostly misunderstood. In physics, the word observer does not mean a human mind. It means a measuring device. An electron does not care if a human is watching or not. Experiments work perfectly with automatic machines, computers, and detectors running alone. What actually matters is interaction, not belief. When an electron interacts with a detector, its behavior changes. That interaction disturbs the system and gives a definite result. This is measurement, not consciousness. Now let us talk about the famous double-slit experiment. When electrons pass through two slits without any detector, they form an interference pattern. This shows wave behavior. When we place a detector to check which slit the electron passes through, the interference disappears. Now electrons behave like particles. The key point is this: the detector changes the experiment physically, not the human mind. The electron is not deciding anything. Nature follows quantum laws. Now let us add some weird but true quantum facts. Weird fact number 1. Electrons are not tiny balls orbiting the nucleus like planets. They exist as probability clouds. We can only predict where an electron is likely to be, not its exact position. Weird fact number 2. Electrons can interfere with themselves. Even when electrons are sent one by one through the double slit, the interference pattern still appears over time. Weird fact number 3. Electrons can tunnel through barriers. They can pass through energy barriers that they should not cross according to classical physics. This is used in tunnel diodes and scanning tunneling microscopes. Weird fact number 4. Electrons do not have a fixed path until measured. Before measurement, only probabilities exist. But remember this clearly. These weird behaviors are not created by the brain. They are properties of nature. Quantum mechanics is strange, but it is precise and mathematical. It does not depend on belief, imagination, or thought. To stay scientifically correct, especially for exams and education, remember this sentence. The wave and particle nature of electrons is an intrinsic physical property revealed by experimental conditions, not by human belief or consciousness. That is the correct understanding. Quantum physics is weird. But reality is not created by our mind. It is revealed by experiments.